there, how's it going? I'm Malorian, and this is going to be a real talk. If you came here looking for my usual hobby type content, this won't be the one for you. I won't be talking about these toys behind me. What I'm actually going to be talking about is viruses. Now, this is something where obviously it's really relevant, something really going on right now, and I'd actually recorded this video before. However, I kind of felt that at the end I was coming across as too preachy, it wasn't really needed. You know what, let's just put that away and talk more about toys. However, as things have gotten worse and worse, and we'll see how things get even, going forward, I thought, like, you know what, I really want to do this. And the reason why I want to do this is that there's a lot of misinformation out there. You'll see a lot of things being posted, articles, memes, blah, 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 blah. And if you just looked at them as face value, you'd be like, oh, wow, this seems to make sense. And that's because you don't really understand how it really works. And so you just believe it. And so I kind of thought that if I could come on here and explain some of these things, maybe that would arm you with that knowledge so that you would not fall victim to these things should you ever see them. So I guess the main thing I should then go to next is, well, why would I even be telling you, right? Who am I? Who's Malorian to be talking about these things? Well, oddly enough, even though I do all these nerdy things now and my job is all boring numbers, my education is actually in microbiology and genetics. This is kind of like exactly right up my alley. In fact, my big core block thesis at the end of my university term was talking about like the origin of life type thing and the different types of as archaea versus prokaryotes, that type of thing. So this talking about viruses is kind of right up my alley. Am I an expert? Absolutely not. I am not an expert. I do not have my doctorate in virology or anything like that. I did used to work in a medical lab for a short little while, but at the very least, what I'm trying to say here is that I'm at least literate, I'm intellectually literate when it comes to viruses and microbiology, so I can at least, present that to you. Now, am I also saying that don't believe all those other things you see on those stupid YouTube channels and memes? Come to me to listen to my stupid stuff on YouTube and my memes. Absolutely not. All the things that I'm going to be saying here, if this is something that's new to you and you're like, ooh, that Malorian guy said this, but I don't know if it's true, absolutely look it up. Absolutely go and check pretty much any microbiology book, but, that's the way you should be doing things, right? We could do a whole separate video on this, but you should be going and double checking any of these things. That's how science works. It's not like a one-time show and that's it. No, you find something, you test it, you prove it, you probably prove it a couple more times, and then you start to really believe it. So let's just go with that. I'm not going to tell you I'm an expert. I'm not going to say that you should just take whatever I say and believe it, but let's really get into it. We've been yammering on. It's 3 minutes in. We haven't even got the viruses yet, so we should probably get started. So viruses. What are these things? What actually is a virus? And I got to say, I could actually do a whole video talking about how fascinating viruses actually are. They're really not even technically living, depending on how you're actually going to be phrasing these things, they're extremely interesting, right? Obviously, if you had a population of possums and you're here you go in your habitat, they would reproduce as long as they had food, they keep on going and living, thumbs up. If you had virus, kind of in a petri dish and they could have food in there and whatever they kind of need, well, they'd all die because that's not how they really work. Viruses depend on having a host that they're actually going to go in there and basically infect and then reproduce that way, and kind of this backwards type of way that they actually do this. Now, the real way that you really want to be thinking of these viruses then is that if you're thinking of a regular, microorganism, a bacteria, whatever it is, and you're thinking about okay, there's, where it splits and then there's two and blah, blah, blah. That's not viruses whatsoever. But viruses are trying to hunt those regular cells down and then infuse them with their DNA or RNA or sometimes themselves, and then use the actual mechanisms and all the resources in that cell to reproduce it until it basically explodes, and then there's a bunch more viruses, they go to a bunch more places, and on and on and on and on. Now, this is not something where they can just do it to everything. They can't just go around and be like, hey, you look like tasty food. Boom, I'm going to turn you into me. No, they actually have to be very, very specialized. The best way to try and think about these things when it's like one cell trying to interact with another cell is basically just like proteins and enzymes, and really like think of like lock and key, that when you really think of these things, think of them as like bumpy potatoes, and in order for them to interact with them, something has to go and click in almost like a key and fit that groove exactly, so it can then change it and unlock it and do what it actually needs to do with it. That's really what's happening when we're talking about proteins and enzymes. And even if you don't remember how it actually really works, just think of it as like a lock and key where it has to be very specific. So really, when this virus is trying to find some cell that it wants to actually get into, it doesn't kind of like just like shoot a hole or slash a hole or something like that. It has to go and actually bind with the receptors exactly or close enough so they can actually get inside, and then it does its thing from inside. Now, with that in mind, that means that it has to be very specific where it goes. And that means that every single virus is going to have some characteristics, of course, of like, this is what it's actually going after. These are the symptoms it's going to produce, blah, 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 blah. And your body is realizing that all these things are trying to actually attack it, right? If you think of your body, you're covered in death. All this skin stuff that you got all over you is just really a layer of dead skin, so that if bacteria, viruses, anything else comes and lands on it, it's just dead skin. There's nothing to interact with. It's just fluffing off as dead skin and nothing's getting in. So there's only certain entry points that the virus can actually get into if it's even going after humans, right? It might be actually designed to go after some other animal, that it needs to get in and get to its real, the juicy spot, wherever it's really designed to go and thrive and live and try and reproduce, basically. So if that's how it gets in, if we're saying like it can't go on your arms and your skin because it's just dead, well, that means it must be going in the other places like your mouth, maybe your eyes, maybe even your nose, something to get past all that and get inside. But what happened when it gets inside? It's going to have to get in there. It's going to find those cells, like we said. It's going to work its way inside those receptors, get inside, take over the actual mechanisms of that cell, reproduce, explode, lots of viruses into more, explode, go on and go on and go on. Now that sounds great, right? That one virus is going in there and it's reproducing itself. However, that's not something that can just kind of last forever, right? If that's how it really worked, it would get into somebody, it would reproduce until basically it kills that host, and then the host would die, and then the virus would die. So that's a problem. So the way that some things like some parasites usually work is something where they get into your digestive system, it's going to pass through your poo and get into something else. Well, viruses don't really tend to do anything like that. They like to try and be expelled by, well, like your breath. So if it can get inside you and get into something that's, well, based on your mouth, so whether it's going in your mouth or throat or lungs or sinus, wherever it's trying to really get at, well, it knows that eventually, because you're expelling out breath and coughing and sneezing, that's going to be expelling it back out. And then that's how it can get to others. So that's a really big key concept to try and think about. But along with that too, realize that not only are viruses extremely specific in the actual cells and species that they can actually go after, they're also very, very fragile. These things are like some of those, like the water bears out there and stuff like that, where they're just like almost invincible and you can radiate them and heat them and cool them and whatever, and they'll be absolutely fine. No, these are very, very fragile, very, very simple organisms that die very, very easily. Something that you can really compare this to is where you're standing right now listening to this video. Just take a deep breath. That seemed really nice and relaxing, didn't it? Well, know that you didn't just breathe in air. Know that as you breathed in, well, you breathed in some dust particles, which was really just dead skin for the most part. Know that you also breathed in a whole bunch of microorganisms, some of them living, some of them dead. For example, you just breathed in a whole bunch of bread mold. All over, basically, the entire world is this bread mold floating all over in the sky until eventually it finds some bread, and then it's going to go on there and start reproducing and turning into mold. That's how bread works. That's how mold works, bread mold, and it's a fungus, and basically it can do that. It can be sitting in there dormant, fall on something, and then that's going to start reproducing after that. Now, the big thing is, though, is that viruses are not like that. They can't just float around dormant. They need to find something. They're very fragile, very susceptible to temperature and to radiation and things like that. So they need something to kind of house them. And the best thing to try and house them is water. Water is very good at maintaining its temperature, keeping things from drying out. And so viruses will typically need to be staying in that. So if we're still thinking about how something's going to be passed from one person to another, well, it's going to need to be expelled out through the breath, but not just from like regular breath. There's going to have to actually be water droplets in there that can house that actual virus, get onto whatever else, and then hopefully, well, if you're the virus, try and find some other cells you can infect and then reproduce again. So very, very interesting, the life cycle of a virus and the way that it actually works. And it's very, very important to keep in mind. Now that we know these basics of what a virus is and what it's trying to do, well, a lot of times what you'll be seeing is questions about masks. Why do masks work? What do masks do? You know, if you look at the size of a virus, it can just pass through the fibers of a mask unless it's one of the really fancy ones. And even then, you know, it's pretty small, so it has to be like a really good one. Well, the thing is that you're not trying to capture the small virus. You're trying to capture that water droplet. So if the water droplet can be stuck on that mask, well, then it's stopping, and that's really it. Another big thing to keep in mind with these masks is that you're not trying to stop the virus from coming in so much as you are trying to stop it from going out, right? If I'm walking around and I'm wearing a mask, and let's say I'm with somebody else who's not wearing a mask and they're infected with the virus, well, if they are sneezing or whatever and those water droplets are coming out, I mean, I guess there's the really extreme thing where I'm like, and like the virus droplet there lands in my mouth and then off it goes. But I mean, that's kind of ridiculous. More likely it's going to land on some surface or my arm or my hands. I might touch it, put it in my mouth. Okay, there's that chance of transmission. And really the answer there is not the mask. The answer is really wash your damn hands before you eat, and don't always be playing with your face and your mouth. And then that's going to stop that way of transmission. What it's really doing then is the other way. If I have this mask and I'm wearing it whenever I breathe out, sure, there might be some singular little viruses that'll go through the actual filters and be out there, but they're basically dead. There's nothing that's keeping them alive at that point. However, anything that's going to be contained in a water droplet will go onto that mask, get stuck, and then there you go. It'll be stuck in that mask. I can be washing it at the end of the day. Everybody's happy. Nobody's infected. Well, except for me, I guess, in that case. Thumbs up. So that's fantastic. And then I guess also with that in mind, why does social distancing work, right? If we're not wearing masks at all, but we're just staying separate, well, then how does that really work in stopping the virus? And I think the best way to always be thinking about this is think about winter. Hopefully you're in a spot where either you have winters or, you know, you're in a spot where you've seen movies talking about winters. And what happens is you see people breathe out and there's a cloud coming from their mouth. Well, guess what? Right now, when I'm talking, this is basically happening. There's water vapor coming out of my mouth, but you're not seeing it. Whereas in winter, it is freezing. It is then going back to basically a liquid, and I can see it as this cloud as it's coming out of my mouth. So knowing that this is happening all the time, realize that this is going out, and that's how far it carries. And if I can think of that, if I'm thinking about winter and when I take regular breaths, I'm shouting or whatever, and how far that cloud would go, well, that's really how far I could be infecting someone. Again, it's not like they're just going to be like, oh, it's going to land in their mouth. Likely it's going to land on some other surface. If they go and they touch it before it dries, and then they're touching their food or touching their mouth, and it gets in that way, that's how they can get infected. So if I think of that distance, which is really going to determine or be dependent on me and how heavy I breathe and the atmosphere and blah, 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 whatever that distance is, if you're past that, well, basically I'll breathe out, it'll dissipate down, and you're pretty much fine. Or it's at the point that by the time it actually get to you, those small little water droplets would have dried out, and now the virus is dead. So hey, that's all fine again. So that's why it's really important to be kind of doing at least one or the other, or even better yet, both, and then you're super duper safe. So the next thing we want to talk about then is like, well, what's the deal with it not really affecting kids so much? You hear these things, especially with this current virus, that, it's really killing off the older people, but kids seem to be fine. Well, there's a couple things to be keeping in mind there. And I think the very first one to be thinking about is just that idea of, again, that vapor cloud when you're thinking of winter. If you have your grown adult and they're breathing out, it's going out there all over the place. But if they're a kid, well, then it'll be that smaller. You don't normally see like this bellowing kid as if they were vaping. It's like this massive cloud coming out. No, they have smaller lungs. They're not usually breathing so far heavy out. So at least them spreading it in that way is going to be reduced. At the same time, we're talking about kids who go around licking things and always touching their mouth and putting things in their mouth. So that's quite the opposite. So I think that's almost like a fallacy saying that it can't infect kids. What you normally would then link this to is this other idea that I also want to touch on with this, which is more so symptoms. Now, let's put a pin in that whole thing with kids and talk about symptoms for a second. Now, what that really means is that if I have this virus, as it gets to a certain point, as long as it's doing negative enough harm to me, then it's going to be showing some symptoms. So like in this case here, the virus is going to be attacking the actual tissues in your lungs, the cells in your lungs. So it has to get in through your mouth or nose or wherever. It has to go down, get into your lungs. And then once it's there, it's basically going to be attacking the tissues and the cells. They're going to be exploding, turning into more viruses. They're going to be exploding. Whole bunch of death in your lungs, which is already bad. Then your body is going to try and counteract this, sending in all the antibodies, covering these things up. Basically think about it just like mucus and slime, and that's also not good to have in your lungs. And know what happens when these things happen in your lungs and you have all that death and mucus in your lungs? Well, you're going to cough. And if you cough a lot, well, then you're going to start having a stuffy nose. You start bothering your nose and. Maybe you're coughing off a headache. Basically, based on what's happening, you're going to be having symptoms after that. One of the things to keep in mind with this is the idea that, like, if one little virus flies into my mouth, I'm not going to just go exploding into symptoms, right? First of all, it has to get in, it has to establish itself, and then it has to establish a colony large enough that my body is now having troubles containing it, and then that's where I'm really going to be showing any symptoms whatsoever. And then if we're talking about when I'm contagious, it has to then be growing so much that now there's a large enough colony that I can actually be sneezing and coughing, having the symptoms, which then would expel it, and having enough of the actual colony for it to be expelled out. So it's not like an automatic thing. One little virus comes in, and then poof, I start coughing and it's going everywhere. Well, no, typically it'd be a lot more than I'm initially being bombarded with. I would be then having at least some established, double, off you go, and then all of a sudden there's now enough. The body's trying to defend itself. There's enough that I'm starting to show symptoms. I'm coughing. There's enough that now when I cough, there's actually coming out of me and the water vapor coming from my mouth, and now that's where it can actually start infecting others. So there's a little bit of that difference. Now, obviously, if these bad things are happening, if you have anything else that's making this even more difficult for you, well, it'll make things more difficult for you. A great example of this is myself, where I have asthma. So with my asthma, when my lungs get kind of triggered, they decide like, hey, know what we need in these lungs? More mucus. So if I actually get infected with this, and then all of a sudden I got my lungs tissues exploding into viruses, and the asthma's coming up and saying mucus, the body's saying kill this, cover it with antibodies, which is just turning into basically more mucus. And yeah, that's just really bad. It turns out with all these things in your lung, it'd be really, really hard to breathe. And so the big thing I want to get from that, though, is that morbidity. So something like that, if you hear somebody died and COVID was a comorbidity, that means that there was multiple factors in them dying. So maybe it was like, I had asthma and I also had this. And between the two, boom, that's why I died. So first point I want to be talking about here is that whenever people say like, oh yeah, if somebody died in a car crash and it was they're going to blame it on COVID. No, that's not where these things are talking about. It's usually someone that's in a bad state because they have this chronic illness or they're old or whatever, and then once this comes here, their body can't fight these things off, and that's what leads them to die, right? So that's a big thing to keep in mind. It's not that, haha, we're just blaming everything on the virus. No, the virus is infecting all these people, and obviously those who have a handicap and a weakness, they're going to be the first ones to die. They're the ones that, like the lions go after the sick ones first, right? It's not like they're blaming the dead deer on like, oh yeah, it was really just a broken leg, but now they're calling it a lion attack. Well, no, the lion, you see what I'm saying there. Let's go to that thing where I was talking with a kid and take that pin out. So kids, why aren't they really showing these things? Well, they tend to be pretty healthy, right? These kids are young. They're in maybe not quite the prime of their life, but they're doing pretty damn well. They don't have any real chronic illnesses yet for the most part. And so if they have something like this, they can kind of get over it. And in fact, some of these viruses, there are no symptoms whatsoever. And that's something that's really important, and also something important to think about is that when you're looking at those people, whether it's the WHO or the CDC or whoever else that's trying to be tracking down these viruses, when all the information they have is these are what we think the symptoms are, these are the people that I think are being affected, and then from this information, they're trying to determine how this virus works. I mean, just try and think of yourself if you were in one of these positions. We're like, okay, we're in charge of whatever country you're living in. People are dying. And I need you to tell me specifically what type of microorganism is doing it. Might not even be a virus. Where it's actually attacking. What are the symptoms? What are the treatments? Blah, 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 blah. And you can see that there's so many different things. And what you would love is to have a symptom where like, as soon as I'm sick, I turn blue so you can just see it. But when you got something like this where maybe there's no symptoms at all. Maybe it's going to be just a cough. Maybe it's going to be a runny nose. Maybe it's the headache thing. Like, it's so hard to track. So many people are giving the people like the WHO and the CDC such a rough time because they were changing their mind as they were getting information. Well, have you ever watched House? That show where as they get more information, they're like, well, maybe it's this. It's probably now this. That's what their whole lives are. That's what their job is being under the gun and having these little pieces of information coming in and doing the best they can on the information they have, trying to warn the public how to keep themselves. But I digress. I'm going totally off here. Let's move on and talk about vaccines and how these vaccines will then actually deal with this virus. Now, we said that what the body does is that when these viruses come in, is that they're going to be basically trying to fight it off, right? Your body doesn't just lie there and wait to die. It has its own immune system. There's antibodies, blah, blah, blah. It doesn't matter if it's bacteria or viruses. There's things there to actually try and protect itself. Again, think about lock and key, where now these antibodies have to be just right to go and pile on whatever is attacking it, and then once it's basically all covered so that it can now not interact with anything else, they'll bring in other things, they'll then go and dissolve it, destroy it, whatever it is, and that's how the body actually defends itself. Again, it's really lock and key. But in order for your body to actually defend itself against these things, it has to have some some knowledge of this, basically, is the best way to think about it. You don't have floating in you infinity antibodies that are ready to fight whatever might be out there. Well, basically, your body knows, first of all, there's going to be whatever you have genetically being born, you're going to be naturally being making. But it's very interesting that how your body works is that actually, as you deal with these viruses and it knows what's been coming in, what antibodies have been working against that, it actually makes more of those. And so if when you first get hit by this virus, you might not have any way to fight it at all. And it's kind of a race to be like whether the virus kills you or whether your body starts making these antibodies to fight it off in time before you actually die. It's a race that most people don't even think about. So wouldn't it be handy if we had some way of actually helping out people? And there's a couple ways of doing it. One is you could just give some people some antibodies and then that can kind of help them temporarily. But what you could do then is if you could give them some sort of weaker strain of the virus, then basically your body could go and beat this hobbled little thing. Know now that's the lock and key I need to be dealing with this. And in the future, if you get infected, they'll be like, ha! I'm ready for you. That's literally what vaccines are. You know, in the past, they might have been actually giving you just like small bits of the actual, whether it's a virus or whatever it is, but now they can do it a lot better. So whether they're, again, taking a weaker strain, so maybe this one here will be very aggressive and doubling, and then this one's a little bit slower. Well, if I give you the slower one, but the locking key is the same between the two, I know that your body will defeat this, and now you know it, so that the aggressive one comes, you're ready. Or, we got DNA and RNA, the two sides of the double helix. If we put in the other side of it, basically, that will then do the same thing in the body. I don't want to get too technical with this, but there's just ways that you put inside the body. It then fights this, has that memory, has those antibodies, and then you can fight that in the future. Now, that being said, lock and key. This has to be very specific. And so we've had some people saying like, oh, well, once we have a vaccine, everybody's safe. Well, that's not really the case. Another thing to really keep in mind with these viruses here is that they're not just like one type of thing. It's not like this is Canadian loony and all of them will be the same shape, the same size, blah, 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 same color, No, these are all very different. Just like if you might want to be thinking about, oh man, even flowers. I mean, just something that's going to be evolving. That's really what you want to be thinking about these things. The reason why they call it COVID-19 is because it was found in 2019, but there's all these different strains of it. I mean, you can imagine at how quickly these microorganisms die and reproduce, that all these little changes with, as evolution works, is going to be happening a lot faster when there's a lot more generations to actually be going through. And so not only can these strains change over time, but there's going to be lots of other different branches going through there. So if I go through and I have, let's say for an example, the antibodies and the defense I need to have for fighting off lions. We were talking about lions before, so let's keep it on there. Well, what happens if I get attacked by a tiger? Does the defense I have be close enough so that any type of one of these cats, it's handling both? Maybe it handles it okay-ish, but not perfect. That's really how it is. Again, lock and key. So this lock and key was really looking for like, okay, it has to be feline shape, long tail, but then it's like, oh, but it's supposed to be a big mane. This thing doesn't have a big mane. Okay, that thing sneaks through. All right, well then that one doesn't work. So as the virus is going to evolve and change, well, then all of a sudden you need to have a different vaccine that's actually going to be dealing with that. And that's why vaccines are going to be important, even if you've already had it, because knowing from other places across the world, the different strains of the viruses that they've been seeing, they can basically give you like a medley of vaccine that's covering you for all these things. They're not really just giving you like one weekend thing, they're giving you several weekend things that kind of cover that whole gambit all at the same time. So that's really important to know. Also really important to know with these strains and things like that is that that's really important for testing. Whenever testing comes up for these same types of things, tests work the same way in that type of lock and key. And so depending on how specific it's trying to look for, maybe it's looking for what is generally just the COVID. So coronavirus is a type of virus. There's lots of different types of viruses. So maybe just like, oh, there's lots of different types of animals, think that like feline is like a type of animal. So there can be a test that's looking for that to see if it's that specifically. They can also be doing other ones, or getting more specific, saying like, is this specific strain of COVID-19? Again, so we've already identified lots of them, so things can be testing for those. And sometimes they're actually just testing to see if your body has that virus. Sometimes they're looking for the antibodies. It really depends how they're designing it, which is then determining on how fast it works. There's lots of different types of tests out there. But again, some misinformation about how, like this test doesn't look for that. It's really not really keeping in mind that there's lots of different tests. So I'm trying to get that out there too. The big thing I want to talk about then finally is, well, how do you actually wipe out a virus? If we have these viruses which are going at us, and I mean, like, man, we've been trying to do so well where we're trying to stay home and we're wearing masks and we're trying to find vaccines. What's actually going to kill off all these viruses? Is it actually possible? Well, it is possible. I mean, like as we said, if you took a bunch of virus and put it in a petri dish where it has like food in there, which would normally be good for like some bacteria, the viruses will die, because unless something else got in there too that was growing on there that I was actually infecting, it doesn't reproduce itself. So really, if you think of how long you would actually have the body being infected and being contagious with the virus, if everybody waited that period and a bit, and like everyone was secluded, all the virus would be dead. And all the human population, it would all be gone, and that's it. Another one is if we had, hopefully, a vaccine that works for everybody. We could almost do the same thing, right? If your body's killing it off so fast that you never get to the point where you're infecting others, it's not passing on. It's almost like the same thing as if you're distant or staying at home away from everybody else, that can wipe these things out. And there's a lot of things like that where we've gotten super close to be wiping out some awful things in the world. However, one of the things we also have to keep in mind is that just how, viruses evolve, we kind of evolved too. And so there's other creatures on the planet. And so we are mammals, and there are other mammals that are here on the planet, obviously. And a lot of these viruses, as they're looking for their lock and key, it is kind of going towards the ones that we care about, going towards mammals. Now, they're usually a little bit more specific, and that's great for us. If it's only infecting bats, then that's hooray. However, mutation over many generations, and then all of a sudden, if there's enough difference where now that lock and key is like, oh, I fit in that human now, over I go. So we can do extremely well to try and wipe out these viruses that are currently affecting us, but we always have to be cognizant that there's always going to be other viruses that are existing in the other creatures on Earth, and there's always the possibility that they'll mutate to a point where they can be infecting us in the future. So that's something that's not good. However, if we all work together, we can keep these things down. We can keep people alive. So that's what I really wanted to share. Again, I know this is probably going to come out a little bit preachy. I'm trying not to make this as like an attack for one side or another. I'm trying not to make this political or anything else. Really, what I was hoping to do with all this is that whenever I've been seeing things out there where people are doing like a meme of like, you shouldn't be wearing a mask because of this, and we don't need to be safe because of this, and it's just blatant just misunderstanding where they just don't understand how it works. And if you share that with somebody else who doesn't know how it works, they're like, yeah, you got a point. And so hopefully if this gets shared around to those people, then they will understand. And if you ever see those memes or those articles, it'll be like, oh no, that's completely false. So hopefully for the people watching this provided something to you. If you know somebody else that is trying to know these things, you can pass it on to them. Do know that there's a limit to how this works. If there's somebody out there and they're just dead set like, no, the government's trying to kill you, and there's the 5G, and they're trying to get the, robots, little nanobots inside of you. Like, some people you'll just never be able to change and be able to tell. But if there's anybody out there that is open-minded whatsoever, and they're intellectually honest and looking to have the right answer, feel free to share this with them. And then again, it's not like I'm the final word on this. I'm not a PhD. I'm nothing else. Take this and then further educate yourself with all the other information that's out there. And again, don't even just look at one thing. If you're like, well, let's go and do a YouTube on what the next thing is on viruses, look up a couple. Make sure that you have that repeatability, something you can actually check and make sure that you can actually prove in the end. All right, there you go. If you have any comments or any other thoughts, please post it down below. But otherwise, we'll catch you later. Bye.